Expand the following function in Laurent's series. F of z is equal to z by z minus 1 into z minus 3 for mod z minus 1 less than 2. First of all, we have f of z is equal to z divided by z minus 1 into z minus 3. We want to return it is in the form a by z minus 1 plus b by z minus 3. So this is z by z minus 1 into z minus 3 and this is a into z minus 3 plus b into z minus 1 divided by z minus 3 into z minus 1. Now this cancel. Now put a is equal to, z is equal to 3, so that a is 0. Now we get 3 is equal to b into 3 minus 1 is 2, 2b. So b is 3 by 2. Now put z is equal to 1, so that b is equal to 0. So 1 is equal to 1 minus 2 is 1 minus 3 is minus 2a. So a is equal to minus 1 by 2. So this is equal to minus 1 by 2 into z minus 1 plus 3 by 2 into z minus 3. So this is our function. Now let's check the region. This is mod z minus 1 less than 2. Just given in the question, but we cannot find any Laurent's series expansion in this region since we have z is equal to 1 and z is equal to 3 as singularity. The region is given by one centered 2 radius circle inside the 2 radius circle. One centered 2 radius circle means this 3 minus 3. This is one centered 2 radius circle. In question we have given mod z minus 1 less than 2, which is this full region. But we cannot find any Laurent's series expansion of this function inside this region since z equal to 1 is our singularity and which is inside the region. So in order to find a Laurent's series expansion of f of z, we want to change this region. This is 0 less than mod z minus 1 less than 2, or we can write as 1 less than mod z minus 1 less than 2. This is the region which doesn't have the point 1. They remove the point 1 and all other portion are in our region. Now this is mod z minus 1 greater than 1 and less than 2. That means 1 radius circle. This is the region, this portion, NLR region. These two regions, in these two regions, this function has a Laurent's series expansion. A valid Laurent's series expansion since it doesn't contain the singularity. So Laurent's series expansion is always defined for the deleted neighborhood of f of z. So this is our function. F of z is minus 1 by 2 into z minus 1 plus 3 by 2 into z minus 3. We can take any two region of this. Both are valid. We get f of z as this minus 1 by 2 into z minus 1 plus 3 by 2 into z minus 3. And we have 0 less than mod z minus 1 less than 2, and also this is valid for 1 less than mod z minus 1 less than 2. If we take this region or this region, we have mod z minus 1 by 2 is less than 1, and any two of this mod z minus 1 greater than 0 and mod z minus 1 greater than 1. Both are valid. Since we have z minus 1 here and we are ready to expand the function about z is equal to 1. Z is equal to 1 is our center. So the Laurent's series expansion always contains the term z minus 1. So here we have z minus 1. And mod z minus 1 is always greater than 0 and greater than 1. These both are valid. Now this is minus 1 by 2 into z minus 1. There is no change needed here. This is z minus 1 and this is 3 by 2 z minus 3. We want z minus 1 here. So z minus 1 minus 2. So that this is z minus 3. Now minus 1 by z minus 1 by 2 into z minus 1 plus 3 by 2 into, here we want z minus 1 by 2. So take 2 outside. From this we get z minus 1 by 2 minus 1. So that we can use the expansion of geometric series. So this is minus 1 by 2 into z minus 1 plus this is 3 by 4. Also we can take this minus outside. So that we get 1 minus z minus 1 by 2. Always remember geometric series 1 by 1 minus z and 1 by 1 plus z. Here we want 1 by 1 minus z which is equal to 1 plus z square, z cube, etc. And this has alternative plus and minus. 1 minus z plus z cube minus plus z square minus z cube plus z raised to 4, etc. And these both are valid for mod z less than 1. So that we can use here 1 by 1 minus, instead of z we have z minus 1 by 2. So that we can use the expansion of geometric series and modulus of z minus 1 by 2 is less than 1. So this is minus 1 by 2 into z minus 1 plus minus 3 by 4 into, this is 1 by 1 minus z minus 1 by 2. So 1 plus z minus 1 by 2 plus z minus 1 by 2 all square plus z minus 1 by 2 all cube plus etc. We can write it as minus 1 by 2 into z minus 1 minus 3 by 4 into, this is series n is equal to, starting with 1, so n is equal to 0 to infinity, z minus 1 by 2 all power, z minus 1 by 2 all power n. So that first term become 1 plus z minus 1 by 2 plus etc. So this is Laurent's series expansion of this function, or we can write it as minus 1 by 2 into z minus 1 all power minus 1 and minus 3 by 4 into series n is equal to 0 to infinity z minus 1 by 2 all raised to n. This is positive term and this is the only negative power. Since z is equal to 1 is the symbol pole, so that we get this minus 1 only. All others are 0. So this is the Laurent's series expansion of the function f of z, and this is valid for the region 0 less than mod z minus 1 less than 2, and also this is valid for 1 less than mod z minus 1 less than 2.